Alright, in this video I'd like to start the next step of our project. Where we left off was last time we added keyboard controls. I wanted to push left to boost the wind leftward, and I wanted to push right to boost the wind rightward. We have 4 lines right here, pretty simple. And then I made this function called constrain, where we give it a left and right bound and we keep it within certain values. I'm thinking we might use that later if we're changing the gravity or the number of snowflakes or something. We might want to keep them within a certain range. Now, our long-term plan is to add visual controls, a slider bar, a reset button, things like that. But if we tried to add those now, and we just put class slider, class button, it would be a mess. Because one thing that happens in a project is that after a certain point, you realize the need for design, you realize the need for organization. Right now, the snowflake needs to know about the gravity. It needs to know about Pygame drawing itself. It needs to know about the height and width, and other things need to know about the snowflake, which means they are tangled up. They are dependent on each other, and if we change one, it messes up everything else. So if I had a slider that needs to know about the wind, that needs to know about the snowflake, that needs to know about Pygame, then any of those along the chain could break the whole enterprise. I don't want that. I want to help it out to be simple. So I'm going to start today by refactoring. Refactoring is when you move things around, change how it works, but the output is still the same. So we'll prepare ourselves for adding these buttons and sliders. And if it happens quick enough, I'll do that in this video. If it takes a while, I'll do it in the next one. So for example, my first goal today is to put the snowflake in its own file. I can imagine that as a type that we use, just like using integers and lists, and the snowflake can stand on its own outside the main. So I'm going to go, well, I'm going to highlight it. Let's go ahead and Control X, and then I'm going to go new file, snowflake.py. This is kind of the classic thing you do in Java or other languages where you got a class, it gets a file. Even if it's pretty small, you don't have to have hundreds of lines. You can just make 20 lines in a little file. Theoretically, we could reuse this snowflake in another program, you know? And I would love to just say that's it. I would love to just hit run and get it going. But of course now, when we run the main file, it doesn't know what a snowflake is. It doesn't know that this type has been defined. So I'm going to import that at the top. Let's say from lowercase snowflake import uppercase snowflake. Okay, so that means, hey, we're going to look in this file, get the code. And now we get to those problems that I was talking about a minute ago. The snowflake needs to know about the gravity, which seems fair enough. I don't want to get rid of that, but if you imagine we had other objects in the world, maybe there were leaves blowing around, maybe there was a car driving, maybe there was a bird, and they all had to know about gravity, we want to make sure they're all looking at the same thing and they're all doing it once, so that you don't have this tangle where my gravity is different from yours and you changed it, but I didn't know that, and now we've got a problem. So they could look in the main, but that could lead to problems if the main is importing Snowflake and Snowflake is importing stuff from main. It could lead to a circular, kind of like an infinite loop situation. Now it wouldn't in this case, but still we want to avoid it. So I'm thinking I want another file, and I'm going to call this config. Config is your configuration info. It's going to hold all the stuff that is just generally true. It's what we call constants, things that are, you know, the gravity, maybe the max flakes, maybe the width and height. All of these are important to know for various parts of the program. If I have a house and the house is going to be a little roof for the snowflakes to slide down with some interesting physics, it might need to look at these values as well. So we'll put it in one place and everybody looks at that one place. Nobody ever changes it. Nobody ever has two steps. They don't have to bounce off of me to you to you. It's just we all look straight at the config. Nobody ever changes the config. And that's as simple as we can make it. So now the main is going to import a couple of those. I guess it doesn't need gravity. But if it did, we could always add that in there. And then the snowflake is going to import gravity, width, and height. So I'm thinking that this is fine, this is fine, this is fine, this is fine. All of the data of a snowflake is internal. The snowflake knows where it is and where it's moving. But that's it. It's just holding on to its own data and managing its own data. If I tell it to update, hey, this frame, do what you got to do. Maybe you're moving a little bit sideways, maybe you're moving a little bit down. Well, the snowflake can do that. And the one thing that it's probably not going to do is the draw, because I would imagine the drawing is something that might change. We might want to draw it in a different way. We might get rid of Pygame and do it with a different graphical library. You might say, hey, I'm gonna port this video game from Xbox to PlayStation, or I'm gonna port this mobile app from iPhone to Android, and you'll change how it connects to the processor, how it displays on the screen, how it gets input maybe, but you don't change most of your data internally. The snowflake still knows what it's doing and how to obey its own rules. I kind of imagine this draw thing is going to be outside of the snowflake. And then we'll just put that in the loop. In fact, it'll be less because we're not even giving it a name. We're just saying, hey, do this thing. So I'm changing self to snowflake because this is drawing all of them sort of externally. And that means if I hit run, it'll probably tell us we forgot one or two things to catch up to the new reality. Oh, we also made a typo. Fair enough. And it says, oh, Snowflake doesn't know about math. Okay, so I could put import math. All we're using it for is to round up, which is, you know, hardly anything. I could just do round +1 or something, but I do like the ceiling function because it's very clear in the name. Ceiling means you're rounding up, and that's what we know at a glance. Oh, they also have random. Oh my gosh. You see, what happens is when you have everything in one file, you don't know how dependent it is on other things. But when you move it to another file, you realize, oh wow, I thought this was simple, but oh, we're using math, we're using random, we're using constants from outside the class. Sometimes a class knows about what list it's in. Like I could have a list of snowflakes, and maybe when they die it would say snowflakes.remove self or something. We don't have that here, but it's a common thing. And as soon as you move this to another file, you realize how messy the code was, and you stop being so smug about it. You know, maybe 5 minutes ago we thought, oh, I have this great program, it works just fine, there's never anything to worry about. And now you realize, well, hang on, there's a lot going on. So what happens if we try to run? Now, I already see one on the screen. It doesn't have a draw method anymore. Okay. So, hey, we have done the thing that I mentioned at the beginning. At the beginning of this video, I said we're going to do refactoring. Refactoring is when you move around the code that ends up doing the same thing, but now you have a better organization, or maybe it uses less memory or something like that. So I've got the snowflake, and now it's self-contained. I've got the config, and now it's ready to be used by other parts of the program. And I've got the main, and the main is the only place that ever knows about Pygame. It's the only thing that ever knows about drawing, our inputs. And so in theory, we could change it. We could say, hey, I'm going to run this using Arcade. There's a Pygame competitor called Arcade that's a similar setup. And so if we were going to use Arcade instead of Pygame, we could keep this snowflake exactly the same and just switch out in here, hey, we're going to call Arcade's draw circle method instead of Pygame's. Now, the next step that I wanted to add is a class for a slider. We're going to have a little bar at the bottom or somewhere where you can drag along to change the wind. Let's go ahead and do that. Even if this video is a bit long, it'll give us a nice unified process to do it all in one. So, of course, I'm going to make a file, and I'm going to call it slider. And in here, we're never going to know about Pygame. We're never going to know about what the slider is doing. It just says, hey, I'm a bar, and I have a little notch. You know, I think we'll probably call it the cursor that you can drag left and right. And this one's going to control the wind. We can have other ones later that control the amount of snowflakes or the speed or the gravity. But this one's going to be wind. So if we drag it left, we move the wind leftward. And if we drag it right, same thing. So I'm going to have class slider. I'm going to hit enter because I always think it looks weird to have something on line 1. It just looks nice to have space above it. And then what's the slider going to have? Well, it's going to have an init method because we're going to create it with certain, you know, starting points. And I'm just going to say x and y because we're going to say where is it. The size, I would probably just go with the width of the screen. So let's go ahead and import from config, import width and height, because it might need to know, okay, how far am I going across the screen? And what this means is if we change this in the config, if we say, hey, the screen's going to be twice as big, well, then the snowflake automatically gets that, and the slider automatically gets that. And we don't have to like chase down all of these dependencies. We can just say, oh yeah, I changed it once, and everybody is looking at that one piece of data. So I'm going to go x and y equals xy. Those are just like the location. This is going to be like the top left corner of the bar. Or maybe x and y will represent the center of the cursor. That's the thing I don't really know about. Self.width, self.height, and this will be the bar for sure. I'm going to say width, and then we just have to pick a number. I'm going to say 30. This could be something in the init. This could be other things. And then I want to have the cursor. Now here's where it gets complicated, because if I say x and y, do I mean the rectangle or do I mean the little circle guy? We'll have to decide on what we want to call that. But I'm going to say the cursor is starting in the middle, so it's width over 2, and then it's going to be like halfway down the bar. So if the bar is 30, it's going to be 15 down, just in the middle, you know. And then, yeah, that's going to have a radius, which I'll say 20, but we could change these. And since this part's going to move, I want to treat that differently. Like where the cursor is, we might want to reset that at some time. So I'm going to call that reset. And then I'm going to say reset. This is good because we're going to use it. Internally, we might have the bar reset itself at certain points. But it's also good because it's a reliable interface. If everything has an init, and everything has a reset, and everything has an update, then our main file can just say, hey, all the objects, reset yourself. Hey, all the objects, update yourself. And then you don't even have to look at those files. You just trust that they're going to do what they're supposed to do. If I use different names each time, maybe one of them was called refresh instead of reset, you know, then they're not as consistent. So right now, that would just hold on to some numbers, but I want to have one thing in mind, which is, hey buddy, I'm going to click on this bar. I'm going to click on the bar and say, hey, or I'm going to click on the little cursor, the little circle, and say, hey, I'm going to drag you around. But before I drag it around, I just have to know, am I clicking on you in the first place? Maybe I'm too high or too far off in some way. So this method, which I've made before on other things, this is a standard type of distance formula, is just to say, hey, I'm giving you a point. Is it colliding with you? Is it inside of this circle? So we have like the, you know, a squared plus b squared equals c squared kind of thing. And what I've done in the past whenever we deal with those is I don't even worry about taking the square root. I just say the distance squared is compared to the radius squared. Okay? So like if I'm 30 pixels away from the center of the circle and the circle's 20 radius, then I'm outside the circle. So I didn't click. So how do we find the center? Well, it's the classic like x minus the other x squared, y minus the other y squared kind of thing. And it doesn't matter what order we do it, because if you're squaring, then it could be positive or negative, doesn't matter. And if you're adding, then you could do the x or y first, it doesn't matter, right? So this is like the y. This is like the y, the vertical part, and this is the x, the horizontal part. But it could go in the other order. And inside it could be click minus cursor or click minus cursor. It doesn't matter because we're going to square it. Okay. And then one more thing, I said I wanted every object to have an update method, but I don't have any stuff to go inside of this one. The slider is not going to change on its own. If you remember, the snowflake changed on its own because it was following the rules of gravity and wind and getting pushed around or pulled down. But the slider doesn't. Like, we're going to drag it if we click and drag, but that might be separate. So right now the update is just empty. I want to have it because if I tell the main to update every object, I don't want to get an error that some of the objects don't have an update. I want to be able to say, well, they all have an update, even if it might contain no actions. So I'm going to hit run right now to see if we have any errors. Well, actually, it wouldn't even know until we import it. So let's import it. I believe we run the main file and it wouldn't even run the other files unless we import them. So I think we have to hit import just to check whether or not I made some typos or something. But I did this a few days ago and I kind of have most of the dumb mistakes already taken care of. But I'm sure I'll find a way to make more dumb mistakes. So right now this is fine. It doesn't do anything. Like, the slider is not on screen. It doesn't have one made from the class yet, but we'll do that in a second. So let's make one. Let's say slider equals slider, and where's it going to go? We need to give it an x and a y. So we want to make it like the x is 0 because it's going to start at the left side, and then the y is like almost all the way down. So I'm going to say height minus 30. That's like all the way down, notched up a little bit, right? And then inside of here, we want to draw it. We can, let's just draw it right here. I'm going to go slider dot, well, we don't know what the actual shape is, so we got to make a little Pygame rect kind of situation. So we're going to say Pygame dot draw dot rect, and then you say the screen and the color, and then okay, here's where we go, Pygame dot rect. Here's where it's going to be annoying, and when I say annoying, I mean a long line that sticks way out. For a rect, you need 4 things. You need the top coordinates of the corner, so x and y, and then you need how far over and how far down. So and since that's never going to change, like the bar never changes, I'm going to peel that off and call it something else and like define it. That might be weird. Let's give it a shot. I don't know what gray is. Let's say gray equals 128, 128, 128. It's half between white and black, right? That should be a gray. Oh, did I do all caps when I shouldn't have done all caps? So what we're saying is, hey, there's a bar. That's going to be the bar on which we slide. We're going to make this cursor, the thing I called cursor, is going to go left and right when we click and drag. Okay. It looks kind of nice how they draw the snowflakes later, so it looks a little transparent. Kind of nice. We'll see if we change that later. So the cursor, we're going to draw that as a circle. And it's going to look weird at first, but I'm going to make it green because I want it to really stand out and be obvious. So I'm going to say pygame.draw.circle, screen, green, which doesn't exist. And a circle. So for a circle, you need 3 things. You know, for the rectangle, we needed x and y of the corner, and then how far over, how far down. For circle, you need x and y of the middle, and then how far out, you know, the radius. So that's called slider.cursor. Those are our x and y of the middle. And then radius is the how far out, you know. So let's hit run and see if that draws. Hey, it draws a little guy. Now we don't do anything with it, right? We can't move it. We can't get a new wind value from where it is, but it's there, right? So what do we want to do next? I want to be able to click and drag. So I'm going to use the same idea we did in our level editor for the platformer game when you like drag a platform over, which is to just have a Boolean that's true, meaning we're in drag mode, or false, meaning we're not. So in here, I'm going to indent that. I don't know why I didn't. Okay. If event.type equals pygame.mouse button up, then I'm going to say drag equals false. So when we let up on the mouse button, drag, which needs to be a thing, will be false. But if we click on the cursor, not if we just click at some other spot, but if we click on the cursor, then now drag mode has commenced. So I'm going to go and click, or no, slider.clicked. They call it event.pause is your position of the cursor, you know. Then drag equals true. So this is like, hey, I'm going to add a little print. What did I do? I'm going to add a little print just to show what I'm talking about. This is to say, like, hey, are we clicking on the guy or not? Okay, so if I click outside and I leave it up, it says up. And if I click on the guy, it says down. And when I let go, it says up. So I click on the guy, I'm holding it, it says down. I let up, it says up. So this is telling us that we're correctly determining what mode we're in. Are we in drag mode or not? This would have to be changed if we added multiple sliders, because you'd have to figure out which one is in drag mode. But for now, it's fine. So I'm going to say the cursor moves based on the mouse in that moment. So I'm going to get rid of this, the key stuff. We're not going to use that. You can keep it in yours, but I'm trying to make my main file smaller just to keep things tight. So I'm going to say if drag, because if there's no drag, we don't have to do any of this. But if we've clicked on the guy and we haven't let up yet, then slider.cursor 0, because that's the x, the first thing is the x, equals pygame.mouse.getPause. That's the when you're in the event loop, you can get event.pause. When you're not in the event loop, you do this. I know it's weird, but that's how it works. And then wind is going to be something. So if I'm getting the position of the mouse, I'm getting the pixel, you know, I'm like 200 or something. We don't want to use that for the wind. I don't want the wind to be 200 or 300 or 400. I want the wind to be scaled to our min and max. You know, like last time we were talking about how it was between -6 and 6. Those are not calculated with any beautiful physics. Those are just numbers I pulled out of wherever that seemed to look nice. So I'm going to say -6 plus slider.cursor 0 times, and then the scale of like, okay, if I'm halfway across the screen, I want to be halfway across the range. Or if I'm all the way across the screen, I want to be all the way across the range, which is 12, because we're going from -6 to 6, because 12 is the, you know, extent of this thing, divided by width. So that means like if I'm just right at the very left edge of the screen, I've hardly moved over at all, then I'm -6 plus 0. And if I'm way over on the far end, I'm -6 plus a lot. Okay, so if we run it now, we should get what I'm aiming for. I'm going to wait a second for the snowflakes to get a good amount on the screen, and then I'm going to say, hey, look at this. I move it to the left, now the wind is left. I move it even more, now it's even stronger. I move it back to the middle, now they're going straight down. By the way, there's still a randomness thing, so they don't go straight down, even if I was in the middle, but they have a bit of a drift. We could turn that off if we like. And if I move to the right, now the wind goes to the right. And if I go all the way, then it goes at its max that we've set, the +6, which is not super strong. You could go a bit higher if you like. So how did we do that? Well, we put things in files, and now the snowflake knows its business and nobody else has to worry too much. We put some stuff in the config. We'll have more later about like universal constants that people need to know. And then we got a slider, which is very simple in here. Like, it just has some basic numbers, and then it has a way to tell if someone's clicking on it. And then the main is where we do most of the work, because it has the connection to the outside world. It gets input from the user and it puts output on the screen. Nobody else knows about the outside world. Like, the snowflake doesn't know how it's being drawn or how it's being pushed around. The slider doesn't know that stuff either. The main is like, like in the body, like anatomically, the most dangerous thing is whenever you have connection to the outside world, right? Like, your mouth has a lot of bacteria because you breathe in and eat stuff. But internally, like, your spleen is doing okay because it doesn't have intruders getting in all the time, or it doesn't have to worry about things getting out. It's just self-contained. It's like the snowflake is like an organ which is not involved in digestion. It's just doing its little job. And the main is the dangerous part. It has to be the immune system of getting intruders put through some process of verification, and it also has to spit out the output. So our main got a little uglier. Maybe we can separate the mouse controls into its own little method. Maybe we can separate the drawing stuff into its own little method, so the main is more of a table of contents. But for now, it's not too bad, and it does fit on the screen. Like, this main loop still fits on the screen, even with my big text for the video. So I'm going to end it there. We did a bunch of refactoring, and we added maybe 30 lines to do our slider. There you go.